Hello, good morning everyone. Welcome back to White Fortress Cybersecurity. Let's begin. तो हम ना कल ये देख रहे थे कि हम मैनुअली आईपी कैसे असाइन करते हैं जब डीएचसीपी अवेलेबल हो तब भी, और अगर हम ईथरनेट से कनेक्टेड हो तब भी। ठीक है, तो आपके कोई भी डाउट्स हो, क्वेश्चंस हो, साइमल्टेनियसली पूछते चलना भाई साथ साथ। एंड मैं एक बार खोल लेती हूँ इसको। ठीक है, नेटवर्किंग फंडामेंटल्स 2 पे थे हम। तो हमारे जो डिवाइसेस होते हैं उनको कौन असाइन करता था? आईपी डीएचसीपी। ठीक है, या फिर हम जो है मैनुअली भी कॉन्फ़िगर कर सकते हैं आईपी एड्रेसेस, है ना? चलिए, तो हमें सबसे पहले कहाँ जाना था? कंट्रोल पैनल पे। कंट्रोल पैनल पे जाने के बाद हम जाएंगे नेटवर्क एंड इंटरनेट में। नेटवर्क एंड शेयरिंग सेंटर में जाएंगे फिर। उसके बाद यहाँ पे आप जिस भी इंटरनेट से कनेक्टेड है, आप वाईफाई से कनेक्टेड हैं या फिर आप कनेक्टेड हैं ईथरनेट से। ठीक है, तो वो आप सेलेक्ट करेंगे। ऐसे करके आपको देखने मिलेगा वो ब्लू ब्लू में लिंक थोड़ा। फिर ये खुलने के बाद ये दिखाएगा वाईफाई स्टेटस। यहाँ आप स्पीड, सिग्नल क्वालिटी, आईपी, वी4 से कनेक्टिविटी है, ये सब देख पाएंगे। देन वी गो टू द प्रॉपर्टीज। फिर प्रॉपर्टीज में जाने के बाद हम आईपी वी4 में जाएंगे। उसके बाद यूज द फॉलोइंग आईपी। ऑलरेडी हमारा क्या होगा? ऑब्टेन एन आईपी एड्रेस ऑटोमेटिकली एनेबल्ड होगा। हम क्या करेंगे? यूज द फॉलोइंग आईपी एड्रेस करके ऐसे इसको स्टार्ट करेंगे। ठीक है, फिर आईपी एड्रेस में हम क्या डाल सकते हैं? पहला आईपी एड्रेस हमारे किसका होना चाहिए? सेम नेटवर्क का होना चाहिए। सेम नेटवर्क का होना चाहिए से मेरा क्या मतलब है? यहाँ भाई मैंने कमांड प्रॉम्प्ट खोला है, मैं आईपी कॉन्फ़िग कर रही हूँ जिससे हम अपना आईपी एड्रेस देख सकते हैं जिस कमांड से। ठीक है, सो अब हम क्या करेंगे? सिंपली यहाँ पे देखो, आईपी हमें ऑलरेडी कुछ ना कुछ वाईफाई ने ऑटोमेटिकली अपडेट कर रखी होगी, दे रखी होगी, तो कोई बात नहीं, हमें जो है बस डिफॉल्ट गेटवे की आईपी पता होनी चाहिए, है ना? अगर हमें डिफॉल्ट गेटवे की आईपी पता है तो हमें अपना नेटवर्क पता है। अब हमें नेटवर्क पता है तो उसमें हम क्या रख सकते हैं? अपने हिसाब से आईपी जो भी हमारी पसंद की है वो हम ले सकते हैं। अगर वो किसी और सिस्टम को सेम नेटवर्क में अलॉटेड नहीं है तो कोई और सिस्टम यूज कर रहा है उस आईपी को, तो कोई मतलब ही नहीं होता भाई वो यूज करने का। ठीक है, आप यहाँ देख सकते हैं आईपी एड्रेस यहाँ पे ऐसे करके 192.168.105 ऑलरेडी मेरे डीएचसीपी ने, मेरे राउटर ने मेरे सिस्टम को अलॉट किया हुआ है। ठीक है जी, एंड ये मेरा सबनेट मास्क है। सबनेट मास्क क्या होता है, आईपी क्या होती है, ये सब ऑलरेडी हम जो है बात कर चुके हैं। आपके कोई भी डाउट्स हो, कोई भी क्वेश्चन हो, किसी भी वर्ड से रिलेटेड, भाई कोई दिक्कत नहीं है घबराने की, तुरंत पूछ लेना चैट में। अदरवाइज आप मेरे को जो है डिस्क्रिप्शन में दिए गए नंबर पे कांटेक्ट करके भी अपने डाउट्स पूछ सकते हैं। चाहे आप किसी इंटरव्यू के लिए जा रहे हो, आपको इंटरव्यू क्वेश्चंस की जरूरत हो, आई विल बी हैप्पी टू हेल्प यू गाइस। चलिए, तो यूज द फॉलोइंग आईपी, देन उसमें आईपी एड्रेस हम क्या देंगे? 192 डॉट, आई होप ये विजिबल हो, वरना मैं थोड़ा इसको और बड़ा करके दिखा देती हूँ। ठीक है, यहाँ पे आईपी एड्रेस हम देंगे उसी नेटवर्क का जिस नेटवर्क पे हमारा राउटर बैठा है। कौन से नेटवर्क पे बैठा है? 192.168.0.0 पे वो बैठा है। ठीक है, आपका 1 डॉट पे हो सकता है, आपका हो सकता है 192.168.1 पे बैठा हो, तो आप वो लिखेंगे। ये स्टार्ट की 3 जो है आपकी वो सेम ही रहेंगी। ठीक है, उसके बाद यहाँ पे जो है मैं क्या दे दूंगी? आईपी दे दूंगी। जैसे अभी ऑलरेडी मेरा 105 है, मैं चाहती हूँ सिर्फ और सिर्फ 5 रखना, कुछ भी दे सकती हूँ। ठीक है, अनलेस वो किसी और डिवाइस को सबनेट मास्क के अपने आप ही ले लेगा क्लास सी का। देन डिफॉल्ट गेटवे क्या है? हमारे राउटर की आईपी, जिसमें हमारे क्या आ जाएगा? 192.168.0.1, है ना भाई? क्योंकि वो हमारे राउटर की आईपी है। उसके अलावा डीएनएस सर्वर भी हमारा जो है राउटर ही होता है, बट कंपनीज की अगर हम बात करें तो वहां पे आपका जो है हो सकता है डीएनएस सर्वर अलग से लगा हुआ हो। डीएनएस सर्वर वगैरह के बारे में भी हम आगे आने वाली वीडियो लेक्चर्स में बात करेंगे। ठीक है भाई, सो ओके कर देते हैं इसको, या नहीं अभी रहने देते हैं ओके करने को। ठीक है, अभी कैंसिल, मेरा इंटरनेट ना चला जाए, मेरे को यही प्रॉब्लम है बस अभी के लिए। वैसे कोई दिक्कत नहीं है इसको भी आईपी को देने में, आप ओके कर सकते हैं इसको। बस मेरे को भी इंटरनेट का खतरा रहता है थोड़ा, स्ट्रीम बंद ना हो जाए। ठीक है, इसको भी मैं कैंसिल कर रही हूँ, बट आपको पता है कि मैनुअली कैसे हम आईपी दे सकते हैं अपने सिस्टम में। ठीक है, चाहे वो लैपटॉप हो चाहे पीसी हो, कुछ भी हो भैया आपका। ठीक है, फिर अब आ जाते हैं दोबारा डीएचसीपी पे। लेकिन डीएचसीपी क्या करता है, इसकी वजह से हमें इतना जो है नहीं करना पड़ता, इसमें जाओ उसमें जाओ फिर आईपी ऑब्टेन करवाओ। ठीक है, आईपी दो उसको जो है, तो डीएचसीपी हमारा काम ना ये वाला आसान कर देता है। कैसे आसान कर देता है, आईपी एड्रेसेस कैन बी असाइंड इधर मैनुअली, हमने देख लिया भाई कैसे होगी मैनुअली असाइन, बाय एंटरिंग देम फिजिकली इनटू अ डिवाइस। और डीएचसीपी जो कि हमारा डायनेमिक होस्ट कॉन्फ़िगरेशन प्रोटोकॉल होता है, उसकी मदद से हम कर सकते हैं। ठीक है, सर्वर असाइंस आईपी एड्रेस टू ऑल दी, डीएचसीपी सर्वर असाइंस आईपी एड्रेस टू ऑल दी डिवाइसेस कनेक्टेड टू अ नेटवर्क ऑटोमेटिकली। ठीक है, तो क्या हुआ, देखो भाई इसकी मदद से समझते हैं थोड़ा सा डीएचसीपी की वर्किंग। मेरा सिस्टम जो है नेटवर्क में आया, या फिर जो है मेरा मैं ऑफिस में गई। ठीक है, हाँ मैं ऑफिस में आई, ऑफिस में आने के बाद मैंने क्या किया अपना, मैंने पावर ऑन का बटन दबाया इसका। ठीक है, ऑलरेडी मेरा वाईफाई ऑन था, मेरा सिस्टम खुला, मेरा ऑटोमेटिकली वाईफाई से कनेक्ट होने का अनेबल था। तो क्या हुआ, मेरे सिस्टम ने भेजा डीएचसीपी डिस्कवर, मेरे सिस्टम ने क्या भेजा, डीएचसीपी डिस्कवर भेजा। हे आई एम न्यू, इज देयर एनीवन हु कैन गिव मी एन आईपी एड्रेस। ठीक है, तो इसने क्या किया, डीएचसीपी डिस्कवर भेजा, जिसमें ये ढूंढ रहा है कि कोई है क्या कि जो मेरे को आईपी एड्रेस प्रोवाइड कर सके, है ना भाई। तो ये कैसे हुआ, ये जैसे ही सिस्टम आया हमारा यहाँ पे, वैसे ही इसने क्या किया, डीएचसीपी डिस्कवर मैसेज भेजना शुरू करा। उसके बाद फिर जब जो हमारा डीएचसीपी डिस्कवर था, ये क्या होता है, ब्रॉडकास्ट होता है, जो भी आसपास के हमारे डिवाइसेस होते हैं नेटवर्क में, उन सभी के पास जो है आपका ये जाता है। फिर डीएचसीपी ऑफर आया। ठीक है, कहाँ पहुंचा है, राउटर के पास पहुंचा सपोज, या फिर डीएचसीपी सर्वर के पास पहुंचा। तो वहां से क्या आया, वहां से आपको डीएचसीपी ऑफर आया। डीएचसीपी ऑफर में उसने क्या कहा, हे श्योर थिंग यू कैन हैव 192.168.1.10। ठीक है, आप ये वाली आईपी ले सकते हैं। ठीक है, ये किसने हमें दिया, ये हमारे डीएचसीपी सर्वर ने हमें बोला कि आप ये वाली आईपी ले सकते हैं। देन डीएचसीपी रिक्वेस्ट, यस दैट वुड बी ब्रिलियंट, आई विल स्टार्ट यूजिंग। वो कहता है, रिक्वेस्ट करता है हमारा जो सिस्टम है कि हाँ भाई ये वाला जो है बढ़िया आईपी लग रही है, ये मेरे को अलॉट कर दो। फिर उसके बाद डीएचसीपी सर्वर क्या कहता है, एक्नॉलेज कर देता है कि हाँ आप ये जो है आईपी यूज कर रहे हैं फॉर द नेक्स्ट 24 आवर्स, ये आईपी आपको 24 आवर्स के लिए असाइन हो गई है। ठीक है, अब 24 आवर्स क्यों भाई, ठीक है, ये भी हम देखेंगे कैसे हमारे डिवाइसेस को 24 आवर्स के लिए होता है। ये चेक कैसे करते हैं, मैं एक बार दिखा देती हूँ। यहाँ पे देखो भाई, मैंने लिखा आईपी कॉन्फिग। ठीक है, आई होप ये विजिबल है, /all। ठीक है, पहले मैं आईपी कॉन्फिग कर रही थी, अब मैंने क्या किया, आईपी कॉन्फिग /all किया है। तो यहाँ अपना पहले तो वाईफाई वाली साइड देख लेते हैं, जो हमारा ऑलरेडी कनेक्टेड है, ये रहा। ठीक है, मेरा वाईफाई से कनेक्टेड है ना, तो वायरलेस लैन अडेप्टर वाईफाई। ठीक है, तो यहाँ पे ये फिजिकल एड्रेस दिखा रहा है एक तो, जो कि हमारा मैक एड्रेस होता है। ठीक है, भी हम देखेंगे मैक एड्रेस भी देखेंगे, हम बाकी सारी चीजें भी देखेंगे हम। तो ये जो है हमारा मैक एड्रेस हो गया। देन डीएचसीपी हमारा एनेबल्ड है, यस, क्योंकि हम वाईफाई से कनेक्टेड है, हमारा राउटर हमें दे रहा है। ऑटो कॉन्फ़िगरेशन एनेबल्ड है, यस। ठीक है, लिंक, अभी मैं जो इसको ऑटो कनेक्शन ऑफ कर दूंगी, ऑटो कॉन्फ़िगरेशन ऑफ कर दूंगी, तो ये जो है नहीं करेगा। लिंक लोकल IPv6 एड्रेस, ये IPv6 एड्रेस है, ये IPv4 एड्रेस है। ठीक है, ये सबनेट मास्क हो गया इसका। ऑल्सो यहाँ आप देख सकते हैं मेरे को कब से कब तक, मैंने अभी अपना सिस्टम खोला था 9:45 अराउंड, तो आप देख सकते हो यहाँ पे मेरे को कब से कब तक इसने दे रखा है, 9:45 से लेके 11:45:53 तक। तो ये अराउंड 24 आवर्स जो है आपको देता है। गुड मॉर्निंग सर, वेलकम टू द चैनल। ठीक है। सो यहाँ पे आप देख सकते हैं अराउंड 24 के लिए हमें लीज ऑब्टेन की, मतलब ये जो है आपका जब पूरा हो जाएगा उसके बाद दोबारा से क्या चलेगा आपका, दोबारा से ये वाला प्रोसेस आपका चलेगा। ठीक है, वापस से भेजे बोलेगा कि उसको डीएचसीपी को कि भाई मेरे को आईपी चाहिए दोबारा से कनेक्ट करने के लिए, तो फिर उसको आईपी प्रोवाइड कर देगा ऐसे करके। ठीक है, तो ये सब ऑल्सो आप यहाँ देख सकते हो डीएनएस सर्वर हमारा क्या दिखा रहा है, हमारा दिखा रहा है राउटर को ही। ठीक है, तो हमारा जो राउटर होता है वो मल्टीपल काम करता है, आपका डीएनएस सर्वर की तरह एक्ट करता है, डीएचसीपी सर्वर की तरह एक्ट करता है, आपके पैकेट्स को कहाँ जाना है प्राइवेट नेटवर्क से निकल के उनको रूट करता है, उनको रास्ता दिखाता है एक तरह से, है ना भाई। तो ये सब पढ़ेंगे अभी हम, नेटवर्क कंपोनेंट्स वगैरह हम पढ़ेंगे। मैंने वैसे भी वीडियो बना रखी है इन सब चीजों के ऊपर, बट अभी मैंने सारी पूरी नहीं कर पाई थी वो उन वीडियोस को, तो यही बेटर है कि मैं आप लोगों को लाइव ही पढ़ा दूं। ठीक है, अब आप बताइए भाई, व्हाट इज द डीएचसीपी लीज ऑफ योर डिवाइस। कैसे भाई पता करेंगे आपके सिस्टम की डीएचसीपी लीज क्या है। अभी मैंने कमांड बताई है, बताओ भाई कमेंट्स में, कैसे हम डीएचसीपी लीज अपने डिवाइस की पता करेंगे। ठीक है, सिंपली बाय, hello, good morning, Arjun. Welcome to the channel. We can start the class in English, but I'm just worried that many of my students were not preferring English language. I can continue with the English lectures too. Okay, sure. Okay, so let's continue in English then, if that's what you guys want. So I opened my command prompt, and here you can see that we have, I put the command ipconfig slash all. Here is the command. Okay, ipconfig slash all, with which we can see our multiple connections to the system. And in this, we are noticing the Wi-Fi one because we are connected to the Wi-Fi. Okay, no problem, Arjun. I am fine with English as well. Okay, so here I already covered the IP V4 stuff in the previous video. So if you want me to repeat that, you can also tell me to do that. Okay, I'm here to solve your doubts only. So we have the physical address over here, which is the MAC address of your system, and we will discuss it in the upcoming lecture. Then we have DHCP enabled, that is your working of your router. So your router provides the IP address to your system. Also, your router is considered default gateway and DHCP server. Also DNS server. Okay, so we will discuss that in the upcoming video of networks, components of network. So basically to check the DHCP lease means the timing uh, for which the IP address is assigned to the system. So here you can see from this 26 August 9:45 a.m. to 11:45 a.m. it is provided to the system. Usually it is around 24 hours, or it could go up to 48 hours. After that, this process of getting the IP address, giving the IP address to the system is repeated. So to check the DHCP lease of your device, you can simply put ipconfig slash all command in your command prompt, and there you will see the lease obtained. Next we have is APIPA. So basically APIPA stands for automatic private IP addressing. So when the router or DHCP server is not, yes ma'am, if you don't mind, can you pass us back? Okay, real on, okay, sure. I can surely just review the IP thing to you. Just a minute. Mm. Okay, so yesterday we got to know that our binary numbers are zeros and ones, which is what your computer understands. Then you have decimal numbers. Decimal numbers ranges from 0 to 9, which is your IPv4 address. So basically, This is my IP address of my device. This is the IP address 192.168.0.106. So the every digit in this you will see will be between 0 or 9, 1, 9, 2, like this. So decimal numbers are used in our IPv4. Then we have hexadecimal numbers. Hexadecimal numbers ranges from 0 to 9 and A to F. Okay, so hex means 6. 6 is your A to F, and then you have decimal means dec means 10. Dec means 10, then that ranges from your 0 to 9. So our IPv6 address uses these. Okay, here also you can see this is the link local IPv6 address, which is the IPv6 address of my device. You can see here every digit will range from 0 to 9 or A to F. Okay, so this is how the hexadecimal number looks like. Then we have IPv4 address example over here, which is the IP of my device, which was yesterday. This was the IP of my device. Then every octet, we have 4 octets in the IPv4 address. Okay, we have 4 octets that is separated. Each octet is separated by a dot over here, and each octet ranges from 0 to 255. If we convert these 0 and 255 into the binary format, you will see 8 times 0 and 8 times 1 over here. So 8 ranges from 8 times 0 to 8 times 1. So particularly it is 8-bit in value. Then we have total 4 octets. So 4 octets, okay, here you can see 4 octets, and each octet is of your 8 bits, because each octet ranges from 0 to 255, and then it ranges from 8 times 0 to 8 times 1. So 4 octet into 8 bits equal to 34 bits. So your single IPv4 address is of 34 bits. Just a second. Then we discussed classes of IP address and types of IP address. So in classes of IP address, we have class A, B, C, D, E. So class A, first octet. So here I told you that we have 4 octets. So the first octet in class A ranges from 0 to 127. So that's why, just a second. So that's why our first IP address of class A will be 0.0.0.0 because it ranges from 0 to 255. And the last IP address of class A will be 127.255.255.255. Then we have class B. Class B's first octet ranges from 128 to 191. Then class C's octet ranges from 192 to 223. Then class D octet ranges from 224 to 239. Okay, so this is, and we also have class E, 5 classes total. Then it ranges from 240 to 255. So these are the main 3 classes, class A, B, C, which are used regularly. And the other 2 classes, like class D, is reserved for multicasting purposes, and class E is reserved for research and experiment purposes. Then also these are the 3 main classes that are used usually, class A, B, C. So they have got something called subnet. Subnet is used basically to distinguish between the host portion and the network portion of an IP address. So here you can see we have subnet mask of class A is 255.0.0.0. Then we have a class B subnet mask as 255.255.0.0 and class C as 255.255.255.0. Okay, so here you can see these are the 3 classes, and this table you should remember. Okay, so this much. Class A, B, C, their ranges of first octet 0 to 127, 128 to 191, 192 to 223, and the subnet mask, these 3 subnet masks of each class. You should remember why to find these things. You have to find these things. Why? to understand how the network works and how the devices have got their IP addresses. Okay, so in class A, so I took an example. The first octet ranges from 0 to 127. So here you can see I have taken 10 as the first octet because it is between 0 to 127. Then we have the rest of the IP. So this is my full IP of class A. I am just taking an example. And we have subnet mask as 255.0.0.0. Okay, here you can see we have got subnet mask. Then we have network address, that is your, how do we just take out this network address? How do we know that this is the network address? That is with the help of your subnet mask. So in subnet mask, 255 represent the network portion, which is helped in taking out the network address as well. Okay, so we have, and rest of the IP represent your host portion here, because in the subnet mask, your three you have got 3 octet as 0, that means it is your host portion. So your 255 represent the network portion in an IP in an in a particular class of IP, and 0 represents the host portion. So next we have broadcast address. In broadcast address, you can see the network address is the first IP address of your network, and the broadcast address is the last IP address of your network. So suppose I have this IP address 10.20.30.50. So the network address of this device will be 10.0.0.0 and the broadcast address will be 10.255.255.255. So the subnet mask is essential to just know these two. Then we also have network bits. I told you each octet is of your 8 bits, and the first octet in the class A is your network portion. So network bits will be 8 bits because only one octet is your network one, and the rest of your are the host ones. So there will be 24 bits because 8 bits of each octet into 3 bits. Okay, these are the host portions, right? So into 3 equal to 24 bits. So number of IPs that can be, so I hope this is clear. If you have any questions, you can just stop me and ask me in the chat. I have no issue to re-explain it, or whatever your doubts are, whatever your questions are, you can just mention them. So now we have got the network bits as well as the host bits. So these two are very useful. One is used for your CIDR mask. This is your CIDR mask. There is no need to just know it yet. We can talk about it in the subnet part. Okay, but multiple times you will see this one. So you can just know this is the network bits. You will see /8, you will see /16, you will see /24. That is just your CIDR mask. Okay, no need to know that yet. Next we have is host bits. So just to know how many IPs, how many hosts can sit on a particular network. So here you can see we have this network address. So, and the first IP is this and the last IP is this. So you cannot imagine how many uh, combinations it can have, how many IP addresses can sit on this single network. So for that we have a formula. We have the formula. So number of IPs in a network of class A. Here you can see class A, and on this network, how many IPs or devices or hosts can be there? It is 2 to the power your host bits minus 2. Why minus 2? Minus 2 is this your network address and broadcast address, because they cannot be used as the host address. So we have this as 16 million plus host. 2 to the power 24 minus 2. There will be 16 million plus host on a single network of a class A IP. So who uses these many IPs or this big network? Your internet service provider. And who provides the IP to your internet service provider? That is your INA. INA is your Internet Assigned Numbers Authority. Here you can see. So they particularly provide IP address, autonomous system numbers. We will discuss them in the upcoming classes, autonomous system numbers and DNS. Okay, so let's continue. Number of hosts. Okay, next is our class B. So it ranges, the first octet ranges from 128 to 191 in class B. So we have this IP 172.30.40.60, just for an example. Okay, because the first octet is in between 172 to, sorry, 128 to 191. So the subnet mask of class B is 255.255.0.0. Now we have to take out the network address. Okay, how to take out the network address of this particular IP? I'll have to check the subnet mask. So these two octets are representing the network portion and the rest two are representing the host portion. Network portion, host portion. So two octets will remain the same. We'll just copy and paste them here, and the rest two will become 0, 0. Why? Because that's how you take out the network address. Then we have broadcast address. For broadcast address, it will be same as the network address, but instead of 0, 0, there will be 255.255 because it is the last IP address of this network address. Next, we have network bits. So network bits, two portions representing the network portion. So 2 into 8 will be your 16 bits and host bits will be your 16 bits too, because there are two octets only that are representing host bits. Next, we have number of hosts. So for the number of hosts, 2 to the power host bits minus 2 equal to 2 to the power 16 minus 2 equal to 65,000 plus host can sit on your single network of class B. Okay, how many hosts? There can be many networks there in the class B, but how many hosts are possible on a single network? They are 65,000 plus. Who need these many IP addresses? Large companies. Next, we have class C. Class C's first octet ranges from 192 to 223. So I have an example of my IP address over here. For say, it is 192.168.1.106. So those who didn't understand yet about the class A or class B, here all your doubts will be cleared. Okay. So for example, this is your IP, this is your system's IP. So here you can see the subnet mask of the class C is 255.255.255.0. So how many bits for the network portion? Here you can see there are 3 octets. So 3 into 8. 8 is your single octet is of your 8 bits. So here you can see network bits will be your 8 equal to 24 bits. So this much is your network portion, means network address will be this 192.168.1.0. This will be your network address. And what will be your broadcast address? These 3 octets will remain same and the last one will become the 255. That will be your broadcast address. So here you can see network address 192.168.1.0 and the broadcast address ending as 1.255. Next we have host bits. How many host bits will be there? 8, because there is only single octet in the subnet mask, which is 0 and representing host bits. Then we have total number of hosts, 2 to the power 8. Okay, we will be putting 2 to the power host bits, that is your 8 bits minus 2. So 2 to the power 8 is your 256 minus 2 equal to 254 hosts. Okay, these many hosts can sit on a single network of your class C. I hope this thing is clear to you. So who uses only this much IPs? We uses it at our home network and at our small office network. So for example, you have this network 192.168.1.0 or 0.0. So this is gonna be the first IP address that will be given to your router. Okay, and then you will have this is the first IP in the network 192.168.1.1. Then you will have 1.2, 1.3, 1.4 till 1.254, and the last one will be used for your broadcasting. Okay, we'll in the further lectures we'll also cover what is broadcasting, unicasting, multicasting, everything. So here you can see it is 192.168.1.255 as your broadcast address in this network, of this particular network. If you have any doubts in this classes thing, you can just tell me, and just take the screenshot of these. Let me show you. Uh, After this, I just told the difference between public IP and private IP. So those who have joined just recently, they can take the screenshot of this one. Okay, difference between private IP and public IP. I hope you have taken the screenshot. And this is an example. So private IPs are assigned to our devices by the router. Router have two IP addresses. I'm telling you again. Okay, router have two IP addresses. One is the private IP, then another is the public IP address. Public IP address is assigned by the internet service provider, and that is what we pay for. And the private IP is also configured by the internet service provider. For say 192.168.1.1 will be given to your router. So this is just take it as a typo. Okay. So and then it will provide the IP addresses of the same network to our devices. Okay, you can just read the difference between in them. Also, we have got static IP and dynamic IP over here. You can also take the screenshot of this. We have four types of IP addresses. Okay, static IP, dynamic IP, and private IP, public IP. So let's continue. Guys, if you have any doubts, I'll be really happy to help you guys. So just ask the doubts in the chat box, or if you got any questions. Let's continue. Then we discussed about the NAT, that is your network address translation. And your router act as a network address translator, which converts the private IP address to the public IP address and public IP address to the private IP address. So basically, we have got some systems in a private night, sorry, private network, and what it will do, it will simply take the packet from here. It will convert the private IP to the public IP by using its own public IP, and then will send it to the server. So for example, this system gonna ask for IP, sorry, for the www.google.com for say, or www.whitefortress.in. So the packet will consist the IP of this, then it travels through the cable or wirelessly to the net to a router, and then the router will change its private IP to the public IP, which is already assigned to the router. Then it will forward the packet. Packet is your data. Okay, for example, the packet contains the data about asking for a particular website like www.whitefortress.in. Okay, then it will send the packet to the server or to the external internet. Then the server will reply back to its IP. Okay, it will reply back to the public IP. Then it will again convert the public IP to the private IP to send it to the specific system, whichever asked for the data. Okay. Next, we were talking about the DHCP. So either we can assign the IP manually by going to the control panel, then internet, your network and internet center. Okay, here, let me show you again. So we go to the network and internet, that network and sharing center, then we can go to the to whatever we are connected to. Either we are connected to the Wi-Fi or we are connected to the Ethernet. So then we will scroll to the IPv4 address, and here we can just click on use the following IP address to give the IP manually to the system. But make sure to give the IP that is of your network, not of some other network. I hope this thing is clear. If you do not configure the IP address correctly, you will not be able to make connection with the internet. Next, we have got the working of a DHCP server. So, for example, a system comes into a particular network and turns on the Wi-Fi connection. Then there you will see DHCP discovery message. Hey, I'm new here. Is there anyone who can give me an IP address? That is how your system asks for the IP address. It just simply broadcast. Then after broadcasting, the request will reach to the DHCP server. Then after reaching to the DHCP server, it will simply reply back with the DHCP offer. Hey, sure thing, you can have this IP address. Then it will say thank you and will request for this IP. It will simply say, yes, I would love this IP address, and it will send it to the DHCP server. Then DHCP server will acknowledge it. Okay, great. You can use this IP address for the 24 hours. And that is what we call the DHCP lease. So to check the DHCP lease of your device, you can simply put the command ipconfig/all. ipconfig space/all. Okay, so there you can see lease obtained, which is the amount of time that is given to your device for the IP address. And then after the time is completed, again DHCP discovery will go. Again, it will ask for the offer. It will offer the IP address. It will request the IP address, and it will acknowledge it. So that is how your DHCP server works. It might provide some other IP address, or it might provide the same IP address. So because of the DHCP working, we call the IP address, IPv4 address or IPv6 address, as logical address. Okay, because time to time it can change due to this thing. So DHCP works on the application layer. Guys, if you have any doubts, you can ask me. Okay, and do not forget to like the video and subscribe to the channel if you want to continue learning from us. Next, we have DHCP works on the application layer of the OSM model, and its port number is 67 and 68. So basically, DHCP is also working on a protocol, that is your dynamic host configuration protocol. And which devices uses this DHCP? It is used by routers as well as your servers. So DHCP works on the application layer of the OSM model, and its port numbers are 67 and 68. So this is done. Okay, what if it sends the DHCP discovery message, but there is no DHCP server available? Hello, Hume, welcome back. No problem. We haven't gone too far. We just discussed the DHCP working only. Okay, so then we have got the APIPA. Yes, yes. Good morning, Hume. So we have APIPA. In APIPA, so for example, our system sends the discovery message again. So it goes to the multiple systems present in the network, but there is no DHCP server available. So what will happen? APIPA, automatic private IP addressing, will happen. So this is the feature of your operating system. For example, your Windows, your Linux have this feature called automatic IP addressing. So how does it work? The operating system, with the help of the operating system, the IP is self-configured to the system. So operating system will self-configure itself. How? It will provide an IP address of range 169.254.0.1 to 169.254.255.254. So IP will be in between these systems. So APIPA stands for automatic private IP addressing. It is a feature or characteristic in your operating system which enables computers to self-configure an IP address and subnet mask automatically when their DHCP server isn't reachable. So there is no DHCP server, then it will self-configure. Also, it will tell the nearby devices as well that this is the IP address I'm taking, so that they can communicate in a single LAN. Okay, if they're connected together with the help of a switch, they can still communicate with each other, but not with the internet, because without the help of a router or a server that is connecting you to the internet, it can only work in the local area network. Only if devices are connected with the help of a switch. So we will discuss what are switches, hubs in the upcoming video. Okay, so the IP address will range from this to this, having how many IPs? 65,534 IP addresses. Why? Because this takes the IP address of class B, right? So with the subnet mask of 255.255.0.0. So I'm telling you again that you have to remember this thing. What are the classes, what is the range of those classes, and what are the subnet mask of those classes. You need to remember this table, and that's all you need to learn. All you need to remember. Other things are just for understanding. You'll understand everything on its own. So what part of the device have the IP address? Now I'm saying IP address, IP address, IP address. But is there is some particular part that have got the IP address, or the whole system got the IP address? So what do you guys say, bhai? What part of the device have the IP address? Do you have any idea? Or is it just the whole system having the IP address assigned? No, there is a part which is called your, guys, I want it in the comments first. Then I am gonna tell you which part have the IP address. Tell me in the chat. I wanna know. Anyone knows it? Anyone know which part is it? No? Okay, let's continue then. We have NIC. That is your network interface card. That is a hardware device that is used to connect a node onto a network. So what is it? Network interface card, which is a hardware device. Okay. So the IP address is assigned to this network interface card. NIC fits is fitted into the expansion slot inside the computer. It serves as a link for sending and receiving data on the network. So network adapter. It Yes, network adapter could be external basically, no? It's an external thing. We already got NIC, network interface card, as an internal thing. Hello, Prabjot Singh. Welcome to the channel. So we have got NIC fitted into the expansion slot inside the computer. It serves as a link for sending and receiving the data onto the network. So basically, we will not say one system is communicating with another system. One system's network interface card is sending packets to the another system's network interface card. So it can support the transfer rate of 10,000 and 100 or 10,000 megabits per second. The user can select an NIC depending on the types of network and media. They can also, yes, they can also select, yes, like just like you said, Prabjot, Prabjot Singh, just you said that we can also have some external network adapters to speeden up the packet transfer, to speed up the packet transfer from one system to another or onto the network. So there are two types of NIC. It could be wired NIC or wireless NIC. Good morning, Patel ji. Welcome back to the channel. So we have got NIC, network interface card, that works on the data layer, data link layer of the OSI model. We are soon going to discuss the OSI model. After all this theory that we are learning, we are reading, that is all for your data link layer. And next we have here you can see this is your wired NIC. Here you can see there are multiple ports available to connect it to the cable. Then we have wireless NICs as well. Here you can see we can just use a network adapter, which is your external and wireless. External NIC like USB NIC are also available. You just connect it to the port, to the Ethernet. Sorry, not to the Ethernet, to your USB port. Then we have Ethernet cards. So similar to the NIC cards, we have got Ethernet cards for the Ethernet connection. That was for wireless and wired too. But it ultimately connects you to the Wi-Fi. And also Ethernet cards are of two types, wired and wireless. There are different types of wired Ethernet cards can be used depending on the type of network and corresponding connectors that is required. The different types of wired Ethernet cards are 1000 base T NIC and fiber optic NIC. So 1000 base, we have got two types of Ethernet cards. 1000 base T means 1000 means your 1000 Mbps is the speed. Base means it is using baseband. T means it is twisted pair cables. Okay, we will discuss it in the cable part. The twisted pair cables can be connected to it, Ethernet. Then we have fiber optic NIC. Fiber optic, you might already know, it is made up of glass. And in 1000 base T NIC, the signals are transmitted in the electrical. The signals transmitted are electrical signals. But in fiber optic cables, the packets are transmitted or the data is transmitted in the light. It uses light. Huh. So what else? This one is faster. Fiber optic cables are faster. And let me tell you about one more thing. If you do not know, we have got something called submarine cables. So for example, I'm transferring data from, aren't these for systems which don't have wireless network adapter built in? USB ones, we have included both. Okay, already inbuilt and not inbuilt, like USB NICs and wireless NICs. These are not inbuilt, but these are wired NICs are inbuilt in the system. Okay, let's continue. I was telling about submarine cables. So, for example, I'm sending data from here to worldwide, right? I'm broadcasting in a way because I'm live streaming. Because I'm live streaming, so these packets from my system are also going worldwide, right? From one country to another country. And how is that possible? To send the data packets so fast, that is with the help of your submarine cable. Okay, first of all, let me show you how submarine cable look like. Something like this. It has got many fiber optic cables inside and then multiple layers of insulation so that light rays do not escape from here or other 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 network rays cannot interfere with the inner ones. So that's why these fiber optic cables are insulated really well. So with the help of these, in the at the speed of light, the data is transported from one end of the world to the another end of the world. Okay, then it is gone to the towers, These cables are then connected to the towers, then it is providing the wireless signal. That is how your data travel from one end to another. And at the speed of light means the packets literally teleport from one end to another end of the cable. Okay, so next we have a submarine cable map. Just a second. Here you can see the submarine cable map as well, or it has got the website as well. So there are so many submarine cables that are submerged in the ocean. Here you can see this is the full submarine cable map connecting multiple continents. Okay. Aren't these for systems? Okay, got it. If these cables are cut out, no one would have internet anymore. Yes, it will not be possible to transfer data from one end to another end of the world. Like by shark or something. No, sharks or something will not harm them. Why will a shark play with it? And you can also see these are very thick and have got so much insulation. Wait, let me show you again. These are on the seabed. Okay, these are embedded on the seabed. So I do not think sharks will even dug up in the sand to just find these out, right? And over the time, these might be covered by the sand or other things, right? Submarine cable. These are just lying on the seabed, right? You can also see over here. So I do not think any shark would like to play with these. And these are very heavy too because of the multiple layers of insulation. These are very heavy. That must be very expensive. Obviously, that is expensive to maintain as well, but that is not our work, right? जिनका काम है उन्हीं को ही करे, वही करे. Then, okay, let's continue. Next, we have is MAC address. A MAC address is a access control address. Is a 12-digit hexadecimal number. So we already know hex means your 6 and dec means your 10. So 16 there will be, that means it every octet will have digits ranging from 0 to 9 and A to F. Here also you can see 001AF and it will be a 12-digit address. I wonder why it is not done through the satellite wireless or something. Satellite is not sufficient at all. It is not uh, with the help of satellite. Only GPS or little bit of communication is done with the help of the satellite. But mostly your submarine cables are used because they are faster. Okay, satellites got the wireless technology, right? It has got infrared rays, etc., etc. But these are faster because light is there is nothing faster than the light. Do you agree, Arjun? The packets literally teleport. Why do you wanna know Starlink? Wait. Map. Um, just a second. Look, first of all, it is not that much efficient, I do not think, as much as the submarine cable. It has got the high speed internet for streaming, video calling, etc. But I think it is very expensive. Okay, it is very expensive. And do you know also satellites have got, just a second. Satellites have got high maintenance as well. And it is very expensive. Satellites are expensive, more than these submarine cables too. These are also expensive, but these are very efficient as well. They have also got the expiry. The satellites have an expiry, right? Pricing and latency is the main reason why we use submarine cables instead of satellite. I do not think satellites are that fast because it has got just rays traveling from here to there, but it's still not in the light, you know. It might be high speed internet, but it's just not sufficient yet. Because look at this now, there are very few countries that have got it available at these, wait line at these, coming soon at these, coming soon in India as well. Here also you can see in Bangladesh it is already there, coming soon in India. And other countries, what about other countries? No Starlink available. Okay, here around Russia or something, no Starlink is available. Then in other few countries like Greenland, your United States, it is available. But it is surely very, very expensive. Starlink available in India, how much does it cost? How much does it cost वाला है ना? One time look fee, okay, from 3,000 to 4,000 for unlimited data. 33,000 and a monthly subscription fee expected range from monthly 3,000 to 4,200 for unlimited data. Okay. Yes. So let's come back to our MAC address. So our MAC address, media access control, is a 12-digit hexadecimal number assigned to each device connected to the network. Now, your MAC address and IP address work together. Okay, so let's take an example. I have to send a mail to you. So I have got your name, I have got your address in it. So your address might change time to time, like just like IP address. अभी क्यों बोल दिया? Just a minute. अभी बोल दिया. अभी थोड़ी ना. अभी तो हाँ, अभी तो आधा एक घंटा लगेगा. हाँ, 12 बजे. हाँ. So, for example, you have got your name and your address. So, your address might change. You might shift from one position to another position. You might be sometimes in your office. You sometimes might be at your home. Okay. So, address might change, but your name will never, right? Your name will never change. So, just consider your name as the MAC address and IP address as your home address or your address. So, primarily specified as a unique identifier during device manufacturing. So this is embedded on your network interface card at the time of your manufacturing, at the time of your device manufacturing. The MAC address is often found on a device network interface card. A MAC address is required when trying to locate a device or when performing diagnostic on a network device. So MAC address is required to locate a device when performing diagnostics as well. Or we can consider MAC address as our fingerprint. Yes, definitely you can also. Something that is static, not changing and is imprinted. Yes, you can definitely take it as a fingerprint or something. So a MAC address is required when trying to locate a device and performing the diagnostic as well. So MAC address and IP address both are very essential. And there is one more thing, R, address resolution protocol. We'll talk about that in a while. So can we change it? Can we change the MAC address? It is already embedded physically. No, but we can spoof the MAC address. A MAC spoofing attack is when a hacker changes the MAC address to their device to match the MAC address of another on a network. So, for example, you and I are sitting on the same network, and I want to intercept. I want to see what you're doing in your system. I want to intercept all the messages. You are visiting a particular site, you are just logging into a site. I want to intercept all of those things. I can simply spoof your MAC address. So what will happen? Router will think my system is your system and will send the packets to my system as well. All the packets will be going through my system. First of all, you said something like you are sending something to the router. It will go to my, it will go through my system, and then router sending something to you, it will also go through my system. So with the help of MAC spoofing, I'm just taking your MAC address, and it is not permanent, it is just for some limited time. So a MAC spoofing attack is when an attacker changes, I just simply changed my MAC address to your device MAC address to gain the unauthorized access or launch a man in the middle attack. So my system will be man in the middle who will be intercepting all your communication between the router and your system. Why don't websites block MAC address instead of IP? Or we can consider, very good question, Hugh. That's a really great question. Why websites don't block? Just a minute. Even I don't know about this. This is a really good question. अभी पता लगा लेते हैं. So first of all, एक बार मैं वो खोलती हूँ. एक सेकंड देना. Suppose this is a network. Okay, I hope I'm audible to you. I think it would be more effective. No, no, it will be so bad. It will be so chaotic if they started blocking the MAC address, because anyone can spoof MAC address then. So I'm saying I'm sitting in the same LAN. Okay, I'm sitting on the same local area network with you. I'm sitting in the same office or the home network with you. We are connected to the same Wi-Fi. So the router will know our MAC address. Okay, it will know our MAC address. It will know our IP address. The switches connected in the network on this particular network will know our MAC address, but it will not send the MAC address further. It will not send the MAC address of our device to the internet, right? It will only send the IP address. I hope this thing is clear to you. I told you router has got it. The packets will be sent to the router, and router will tell its IP address that I need data from this XYZ server. Then it will return data to the router, but it will not send the MAC address any further. But it will know the MAC address of the following. That's why only it will be able to send the data right back to the device which it was meant for. Yes, that's why. And this is very effective, that it only blocks the IP address, not the MAC address. If it started blocking the MAC address, and which means it will be getting the MAC address of our devices, right? And which is not very it is not a secure practice. If your MAC address could be traced, it is not a secured practice on the internet. So here also you can see, I told you there are 12 digit number. MAC address is your 12 digit number, and it is separated into 6 octets, each octet containing 2 digits. And the first 3 octets are the organizational unique identifier and network interface. So these 3 octets represent the company which provides the MAC address. Okay, we have something called MAC vendor or something, I think. MacVendors.com. So for example, I have got this find MAC address vendors now. Okay, I am just copying my MAC address, my physical address. Okay, wait. Have I got some other MAC address too? Okay, I'm gonna just copy this one and pasting it here. Then hit enter. So here you can see it's saying Azure Wave Technology Inc. Okay, so the first three are the unique identifiers of the MAC address vendor, and the remaining 3 octets are the unique identifier for a system. My, I need some medicine. Okay, coming back to here. Yes. So why there is a MAC address when we have IP addresses? First of all, what is the MAC address of your device? How will you know that? If I only want to take out the MAC address of my device, how will I check that? Do you have any idea? Can anyone from this MAC address find out who the device was sold to? No, 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 not that. No, it's not possible. From MAC address to find out the device was sold to. The, I mean, we cannot do it, but yes, other people who are in the cyber police or something, they can definitely do it. So there is a command for checking your MAC address, that is your get MAC. So here you can see it is giving me so many MAC addresses, but the main one is this one, which I just copied right now on the top. The rest IP addresses you can see they are all starting from 0A, 0A, 0A. They are used for my what do we call it? VM, virtual machine. So these are for my virtual machine. If your system do not have any virtual machine, it will only show 2 MAC addresses. Okay, first will be your which is your Wi-Fi or Ethernet MAC address, and the second one will be your Bluetooth. Here you can see media disconnected. If I connect it to my Bluetooth, it will show the device connected over here. This is my Bluetooth MAC address, which is same as my Wi-Fi MAC address. And rest 3 are my uh, virtual machine MAC addresses. Yes. Guys, please like the video. Let's continue. So get MAC ho gaya, then let's continue. So we already have IP address, then why do we need MAC address? When we have private IP, we have got public IPs, we still need MAC address. Public and private IP addresses can periodically change, right? They might change. Private IP will be changed by your router time to time, and public IP can be changed by your internet service provider. So your internet service provider or network administrator can change your IPs. MAC address are permanent, but your MAC addresses are permanent because they are embedded on the network interface card at the time of manufacturing. So MAC and IP addresses work together for communication between multiple devices. IP is used for locating the device, and MAC address is used for identifying a device. Just like I told you, here you can see when the server will return back the response, it will help in the discovering of the network. It will discover, yes, it has to be sent to this router. But to identify which system, it has to be sent back. The request has to be sent back. Router will use the MAC address for it. So the request was coming from this address. So it will also log means it will save in its table. It will make a MAC table. Switches also make MAC table. Multiple devices store the MAC table. So it will just make a table in which it will store the IP address, MAC address of the device and the port number to which it is connected to. Guys, if you have got any questions, you can just ask me and I'll be really happy to answer your questions. You can just tell me in the chat. So next is, so MAC address work together. So IP and MAC address both are very important and they work together for the communication between the devices. IP is used to locate the device and MAC is used to identify a device. So example, IP is like your home address. I already told this example, and MAC is the name of the person receiving the data. Means name will not change, but the home address might change. So next, I already told this thing. No need to again tell this one. Activity, what is the MAC address of your device? So put the command in your command prompts and check the MAC address of your devices. How will you do that? Tell me the command. Everyone, tell me the command that will be used for identifying your MAC address of your device MAC address. That is your get MAC. I just receive your messages a little slow. So do not delete them. I'll make sure to answer all your questions. ifconfig, no, get MAC. With ifconfig slash all, ipconfig, sorry. With ipconfig slash all also you can check the MAC address. But get MAC can be used. Get MAC. Here you can see get MAC is the command. Or ipconfig slash all. If I simply put ipconfig, here also you will not find the MAC address. Okay, here you cannot see. If I just put ipconfig, you will not see the MAC address. I put ipconfig slash all, you can see the MAC address over here on the multiple interfaces, or I just want the MAC addresses, I can simply put the get MAC and I will get the MAC addresses. But if you use Linux, in Linux we have command IP hyphen A, I think. For in Linux you can put IP hyphen A for the MAC address. ifconfig will not work in the Linux as well. I hope this thing is clear to you guys. So is data transferred in one go? So I'm sending my file to your file. It just jumps from my system to your system. No, right? So how does it work? Here we're going to talk about the packets now. So we have got packets. Packets are used for efficient and reliable transmission of data. Okay. Instead of transferring a huge file as a single data block, sending it in smaller packets improves the transmission rate. So, for example, I want to send a file from my system to your system and it is 2 GB file. Okay. It is a 2 GB file. So while sending the file, it will first of all convert into small packets, and then one by one the packet will go from my system to your system in a sequence. Also it will be routed by the router, and it will also improve the with the help of router, the transmission rate will also be improved because router will choose the best path for each and every single data packet. kind of what torrent download does, takes little bits of data one at a time. It's just not torrent, it's everything. If even if I'm opening a website, even if I'm going to www.whitefortress.in, okay, here you can see it's taking some time to load. Packets are sent to my device one by one. Oh, take this one, take this image, take this, take that. Slowly it is gonna send the packets to my system, and ultimately this will open. Which layer is packet on? Which layer is packet on? Packets are basically on the network layer, okay? But this we will cover in the OSI model. Okay, this will be, I'll tell you OSI model very explained manner, in a very detailed manner. So do not worry about the layers of OSI model yet. Packet sniffing, packet sniffing means I am able to intercept your packets, your device packets into my device. Just how man in the middle attack we just discussed now. Max spoofing, man in the middle attack. Packet sniffing, sorry, also means that we are able to intercept your packets into my system. Something like that. I hope this is clear to you guys. So packets are used for efficient and reliable transmission. So they are sent in the order, and even if a packet failed to reach the destination, it is resent. But if we send a particular file as a single data block, there might be some errors. Ma'am, what are the CompShare security plus relate to the, huh? What are the CompShare security plus related to MAC address? How can CompShare security plus relate to the MAC address? I do not get it. Arjun, can you explain what you mean? I'm confused now. I did not get your question, Arjun. Please repeat. So packets also enable multiple computers to share the same connection. Okay, so for example, I am streaming at the same time. I'm able to just go to the just wait. At the same time, I'm messaging someone. Okay, with my own device. Just giving an example, and also I'm able to open some other website, whitefortress.in, and in the background, for example, I'm sending file to someone. I'm able to do so many things simultaneously. That is only because of the packets. Arjun, can you explain your question? Also, guys, I yesterday told you about the good news, right? So here is the quiz. You can check this out. And I think I need to update this one. It is the older one. And also, you can give your resumes to our number that is in the description, and we can review the resume for you. Also, if you need mentorship from us, you can still contact us on the same number that is in the description below. So, packet is divided into, so to explain the packet, it is divided into three parts, three main parts. There are multiple things in a packet. It is a very complex one. But for the beginning, to in the CompShare Security Plus uh, exam, what are the possible questions in a MAC address? I do not know, Arjun. You can simply like chat GPT them. Okay. I do not have any idea about the CompShare Security Plus exam. I know about the CH one. And what I do not think whatever I'm teaching you, anything could come outside from there. Okay. Everything will be in this or around this only. And I'm trying to be very detailed over here. Next, we have packets. having three parts. First is your header. Header will store some necessary informations like IP address of source and destination devices, MAC address of source and destination addresses, port numbers of source and destination, things like that. Then payload will contain the data and trailer will be the end of the packet. Thank you, Hume. Thank you so much for your appreciation. And I'm also happy to teach you guys. Next is the data transmission. So data transmission got three types. First data is transported in electrical signals. Next is your optical signals, then your wireless signals. So electrical signals transmission is achieved by representing data as electrical pulses on a copper wire. So in the regular wires or copper wires, they are transported from one side to another side in the electrical signals. In optical signals, the data is transmitted in the light pulses. Just like I told you, fiber optic cables are used for sending the data, and those signals are optical signals. Signals are basically just your data going from one side to another side in bit format in signals. Then from bits, it is converted to the signals. So transmission is achieved by converting the electrical signals into the light pulses, and we have got wireless signals that is achieved by using infrared, microwaves, or radio waves through the air. So we will discuss all three in the cables. We will discuss the copper cables. We will discuss the fiber optic cables. We will discuss the wireless signals as well, signals like infrared, etc. So we have got three mode of communication: simple duplex, half duplex, full duplex. So in simple duplex, so it's like right now I can share the video, I can share the audio with you guys, okay, or the radio stations can simply broadcast, but it is just one way. You guys can chat, right? But you cannot send the like your voices to me or your video to me. So this is like a one way transmission of data. So in this type of transmission, data is transmitted in one direction only. Example, your radio stations broadcast whatever the data, audio, music, or whatever. But those who are receiving the data cannot reply back the same way. And next you have data logging systems. Like data logging system, what do? They just log the data. They just save the data into the database. For example, yes, television also. It is also unidirectional and simple duplex, you can say. So logging systems also, we are able to put data into it, log data into it, but they cannot just send data to us, right? They just store the data. It is also in one direction. I'm enjoying this lecture. Can I buy you a coffee, ma'am? Thank you so much, Arjun. No need to buy me a coffee. Just I want you learn from us. You daily join the lectures and just learn from us. That's it. Nothing else is needed. Also, if you need mentorship, you can contact us on the number. If you have any doubts, then also you can contact us on the number that is in the description below. Next, we have got half duplex. In half duplex transmission mode, two or more interconnected devices exchange data alternatively. So, what happens? For example, you have got walkie-talkie. So, what I simply do, I first of all speak something, then I say over and out, right? I say over and out. Then you speak something and then you say over and out. Only one person at a time can speak or the data collision will happen and no one will be able to receive the data properly. So in half duplex transmission mode, two or more interconnected devices exchange data alternatively, not simultaneously. So at the time A is sending, B is receiving. At the time B is sending, A is receiving. So example of half duplex is walkie-talkie. Next, we have got full duplex. In full duplex transmission, both sides can transmit and receive data simultaneously. So, for example, on the phone calls or on the video calls, we can simultaneously send the data to each other, right? Example of full duplex is your telephony system as well. Data can be transmitted on the both directions simultaneously. Next, we have got types of communication. Satellites, yes, it is like for your unicast. No, not unicasting. What do you mean by satellites over here? I didn't get it. It's not simple duplex. No, it is not half duplex. Satellites are full duplex. Yes, full duplex, and I will count it as because are used for full duplex, not exactly they are using it, but they are used for full duplex. Next, we have type of communication. In this, we have got unicast, multicasting, and broadcasting. So, unicasting means one-to-one communication. For example, I am sending some data to him. Okay, so that will be your unicast, one-to-one. In this case, there is only one sender and one receiver. Multicasting happens when one user sends message to multiple users at the same time. So, for example, I am sending notes on a group. So, I'm not sending to all my contacts. I am just sending it to a specific group of contacts of mine. So, it will be there will be one sender and multiple receivers will be there. So, this is your multicast. Multicast happen when one user sends message to multiple users at the same time. In this case, there is one sender, multiple receiver. Next is your broadcast. We already know what broadcast is now. Broadcast happen when a user is sending message to all users connected or in range. In this case, there is one sender and all others are receiver. So, for example, I am right now broadcasting. So, all others are receiver. Whosoever just open this one, and there is one sender, others. Everyone is the receiver. So, here you can see unicast is one to one, multicast is one to many, and broadcast is one to all in the simple language. And guys, please do like the video and subscribe to the channel and keep learning from us. So now how do they know where to go? How do packets know where to go, right? How do data know where to go? So it is with the help of the ARC. So let's understand the ARC with the help of an image first. We have got device A, device B, device A wants to send data to the device B. So it simply says I'm looking for, so first of all, it needs IP address and it needs MAC address of the device. So somehow it has got the IP address because it wants to send the data to device B. It has the address. MAC address is Hume. I receive your messages a little later, so I do not know which thing you are talking about. Okay, how do they know where to go? With the help of MAC addresses. Not ex. Yes, IP address, MAC address, and ARP. Okay, I told you there are three things: MAC address, IP address, and ARP. These three together play a crucial role in sending the data. I got it. What you meant by it? Okay, so how does ARP work? ARP helps in requesting the MAC address. So I'm looking for this. For say it says device A says कि मेरे को I need this specific IP address. Then it will say what is your MAC address. This is your ARP request. Device A is ARP. ARP is address resolution protocol requesting for the MAC address of the another device. So it simply says I'm looking for this. What is your MAC address? Then it it will go to the router. This ARP request will go to the router. Router will simply broadcast it. Your ARP request is always broadcasted. So it will broadcast the ARP request. Then after that, It first of all reaches this message. I am looking for this IP. It will reach the device C. Then it will reach the device B, D. It will reach all the devices. What will happen? So first of all, it reaches the C device. It will say I'm looking for 123.10.20.2. It will say I'm 20.3. It will drop the packet. It will go to the device D. It will say I'm 20.4, not 20.2. It will drop the packet too. Then it will go to the device B. Device B will be like, that is main device B and here is the MAC address. So it will reply back with the MAC address. Then the router will take this MAC address to the device A. Here you can see this is called your R reply. So let's see. So MAC IP R address resolution protocol, that is a allow devices to identify themselves on a network. ARC, that is a address resolution protocol. What is it doing? Its name says everything. Okay. ARP is your address resolution protocol. It is resolving IP address to the MAC address. So this is the meaning of its name. ARP address resolution protocol is the network protocol used to find out hardware or the MAC address of a device from an IP address. It is used when a device wants to communicate with some other device on a local network. So, to communicate with each other on a local network or the multiverse, multiverse of madness. Oh my goodness. Okay. So it is used when a device wants to communicate in the same LAN, same local area network. So it sends the device, the sending device uses the ARP address resolution protocol to translate the IP address to the MAC address. So the device sends the ARP request message containing the IP address of the receiving device. What will happen? The device send ARP request message, right? The sending device will send the ARP request message containing this message. I'm looking for this and what is your MAC address. So it is just the theory of what I explained just now. All the devices on a local area, local network segment see the message, but only the device that has the IP address respond with the ARP reply message containing its MAC address. So all the devices will receive, all the devices will see this message, but only the device that has got the same IP address will reply back with the ARP reply. The sending device now have enough information to send the packets to the receiving device. Okay, it after getting the MAC address, it will have enough information and then it can simply uh, send the information from one end to another end. Now they can transfer the data. ARP request packets are sent to the broadcast address. Okay, I just told you that ARP requests are always broadcasted and all operating system maintain the ARP cache. Okay, this is a very good thing that every operating system maintains a ARP cache. How will you check the ARP cache of your device? Anyone have any idea? That are checked before sending the ARP request message. So before sending the ARP request message, they first of all check if we already have the MAC address of a particular device. If they do not have, then they will send the ARP request message. You can display ARP entries in the windows by using ARP-A command. So this is the simple command. So I'm going to show you over here. I simply put, let's just clear this. Nice. So I'm just putting ARP-A command. And here you can see this is the ARP cache of my device. So it has got multiple IP address over here. This is the broadcast address. Broadcast address would be always, the physical address of broadcast address would be always like that. FFFFFFF, something like this. Okay, if there are, here you can see on this interface, multiple devices are connected like 101 is in the same network and 1041, okay, this one only. These are the, so this is the MAC address of my router. This is the MAC address of some other system connected to my Router, can you share the slides notes? I can share the notes, but we usually do that in the paid courses. We provide you shared, we share notes with you, we share the class recordings with you, and real time doubt solving and everything. So we cannot provide the doubts, the this thing to you. Okay, let's continue. I have got all the notes as well, even the Word format in the PDF format. Let me show you modules. CCNA. There are more notes. This has got, it has got like 10, 20 notes, CCNA. Let me check. Okay, these are all the notes I've got. So like networking fundamentals. Just a second. So this is our all the notes. It has got everything: static IP, private IP, special IP addresses, DHCP, APIPA, NIC, MAC, mode of communication, multicast, everything. Okay. I cannot share the, like, I have just direct notes as well, the full notes, but I cannot share them because we have got paid courses. So the people who are paying, they are not paying for just nothing, right? So we got this one. Okay, this one is over now. Okay, this ARP one is also over. So next topic we are going to cover are TCP, UDP, everything in detail, ping, ARP. You learn a lot. Okay, then we have next six at sixth module we'll be covering the topologies, I guess. Yes. So next we'll be covering the topologies in the networking fundamental 6. So there are total 10 parts of this networking fundamentals. Then we will continue with the practical part. Okay, we have got Cisco Packet Tracer. Here you can see it's just taking some time to open. So all the practicals will be done, like how to configure the router, how to configure the switch, how to configure the switches. Yes, almost should be. Just want to show you Cisco Packet Tracer interface. And here you can see multiple devices like your routers, your switches. We have got everything. This is your switch. Okay, then in this we can see how it looks physically. Then we can also configure it from the command line, or we can configure it from the graphical user interface. Mostly command line interface is used to configure the devices. I will teach you each and everything how to use this whole Cisco packet tracer thing in a very complete manner. And thank you so much guys for watching, and thank you so much for your support everyone. And I'm really happy to have you guys as my students. And see you tomorrow at 10, 10 maximum 10:50, not later than that. Thank you for watching everyone, and see you tomorrow. Do not forget